Okay, good. This one already recorded. Okay, so what we do now, okay, each one of you, okay, must involve in this presentation. Okay, you must contribute your part for this presentation, and then for each group, after you finish, okay, after you finish, so we will open for Q&A session. Okay, if you have any question, you can ask them. Okay, and then later, at the end of the presentation, I will wrap up the session for today. Okay. All right. So, Shafizal, can you start your team? You can share your screen as well. You can start a presentation now. So I will switch off my video.
So everybody can see my slide, is it? Everybody can hear me? Hello? Doctor?
Yes.
Can.
Oh, okay, good. Okay, this is my team topics, benefits, and the drawback for the
Shafizal, I couldn't
benchmarking.
hear your voice. You are presenting now?
Yeah, I'm presenting now. Can you hear now? Testing 1, 2, 3. Can you hear me?
I cannot hear your voice on my screen.
Others can hear me or not?
Can someone speak so I can hear your voice? Whether
Yes.
my microphone okay or not?
Hello, hello, testing.
Chai, is it?
Yes.
Yeah,
Let me
so you
check
can hear
my
me, is it?
speakers.
Yeah, I can hear you.
Okay,
Okay.
my speaker should be supposed
Can
to
you
be
tell
okay.
doctor you can hear me? So he is the problem actually.
I think Toto's not here.
Hello, Shafizal, I can hear you.
Yeah, I cannot hear
Okay.
your voice. How?
Toto can hear my voice.
Oh, really? Other can hear your voice? Okay, let me take out this speakers. Okay, my speaker. Okay, can you try? You know,
Can you
wow.
hear me, doctor?
1, 2, 3.
Testing 1, 2, 3, doctor.
Yeah, suppose okay.
Testing 1, 2, 3, 4, 5,
Yeah,
6, 7.
I can hear your voice now.
Okay. Can I start
Okay.
now?
Can. Okay, thank you.
Okay, this is hello everybody. I'm Shafizal. Our teams will present you about the benchmarking, the
Okay.
benefit and the drawback. So my name is Shafizal and my another team member is Aminu and Liu Jiao. So as an introduction, what is the benchmarking? Benchmarking is defined as a process of measuring products, services, and against those of organization known to be leader in one or more aspect in their operations. So benchmarking have two types, which is internal benchmarking and external benchmarking, where the internal benchmarking is the comparison of practices and performance between teams, individual or group within an organization. And the external benchmarking is the comparison of organization performance to industry peers or across industries. Benchmarking generally benchmarking process are planning, collection of information, analysis of data, implementation, and monitoring. Benchmarking process are widely used in industries around the world because of the benefit gained from this tool. However, this tool have a drawback that we discuss later. So for the first benefits, an example of it is the improving product quality, where the companies use others competitors or others company products to study their advantages, the way they do product to improve their product quality. Engineers sometimes purchase leading competitor product and they will tear them apart and reverse engineer, reverse study to understand the differences between competitors' product and their own product. Example like car manufacturer. Nowadays we can see that Proton compare with Honda and BMW in the same class. Proton come up with X50, and in the YouTube video so we can see the comparison of HRV and the X1s. It shows the performance difference, and Proton come up with the best value for money, and they also use this comparison as a marketing tool. However, the drawback for this kind of methods is a costly affair. In order to obtain the sample to study, initial costs must be covered. Costs can be in the form of the sample itself, like car. It's not like buying one car. They have to buy a lot of car because one car might be to tear apart, another might be used as a whole to study the performance, and also manpower. Employ highly experienced and skilled person to do the analytical and reverse engineering tasks, because normally unexperienced they can't find the differences between the competitor's product and theirs. So time is money. By doing the reverse study, and it will increase the operation time and management time, so it increase the cost. And tools, another thing is tools. Special tools may be purchased to cater the sample design requirement, because different kind of product have different kind of method to take off or to study. So for the another benefit, I pass to Aminu.
Okay, Aminu, you can continue presentation.
Pizza, please share the slide so that I will read. I will go on with my own part. Hello, Shafiza. Can you hear me? Shafiza?
Yes, hold on.
Okay, share.
Can you see?
Yes. Hello, everyone. Good evening. My name is Amina Abubakar. I am here to present our group assignment on benefit and drawback of benchmarking. As from this first speaker, define what is benchmarking, the types, and the process. So I will go on with the benefit of benchmarking number 2, which is increasing sales and profit. So in any benchmarking company or organization, excuse me, today I'm not feeling fine, but I will inshallah try and present. In benchmarking, a company that uses benchmarking to improve its function operation, product and services may enjoy increase in sales and profit. So the benchmarking company may also promote improvement through company brochures. So in this increase in sales and profit, so in every business, there must be a sales. Then you consider your sales, how it is being to your customers. Is your customers like your product? If they are buying it, are you gaining the profit from what you are selling? Like what Prop give us example in one of the private company he work with, they will give the money for the product, and they will ask if we spend, for example, 1 million ringgit, what will be our profit within the money. So the example of this benefit, we have metric identification, we have data collection, we have compare and contracts, where you compare with your own product and another company product to see, since benchmarking is you to compare with your own product and another company product in order to see what you are going to improve in order to supersede the other company, in order to beat them in the customers to come and buy your product. Then we have step number 4, which is focus on action. We have sustain improvement. Then the drawback and the example. We have lack of customer satisfaction. In each business, companies and organizations, they are trying to satisfy their customers. If you are not satisfying your customers, all your customers, they will go to another product. So in each business, you have to try always to improve in order to satisfy your customers. Then the example, we have not treating the customers with respect. Sometimes some companies or some customers cares in an organization or company, they are not treating their customers. So with that, some customers, they will leave that product, they will stop buying the product from that company. Then we have lack of effort from customer service personnel. We have not delivering according to expectation. In this example, you place an order for a product which you want. So on the delivering from the company, they will deliver substandard from the standard you give them. You give them standard. I need this so specification. For instance, a company which they are producing shoes. So you go there, you give them your own specification, you give them the size you want, the type of the quality, the color, and so on. So in the delivering your own the product you sorry, the product you buy, they will not meet the requirement you give them. So this thing also, the customers, they will leave the product and go for another company. The not being with customer, lack of empathy with customers is yet another reason for a low customer service at levels. So the last one, we have failing to focus on customer experience. In this section, the customer I'm sorry, at the level can be result of not focusing on customer experience. It is essential, but that you try to focus on customers. So in benchmarking companies, all what they need is to focus on their customers, to focus on the other companies to see, to compare with their own product to another product. So it's every company who's rely on other companies' product or benchmarking, sometimes they will fail. Thank you, Prof. and the colleague. That's my own part.
Okay, thank you. Next, Lieja.
Yes, Professor. Can you hear me?
Yeah, can. Very clear.
Yes. Good afternoon. There is a lot of benefits and drawbacks in benchmarking. I chose a piece of it. The future development space of enterprises is predicted by the success of benchmarking. It shortens the gap between the management level and the development level of enterprise. During the process, it reduces business development costs and opportunities for frustration and improve efficiency. For example, Baoshan, Aero and steel is the latest modern steel complexes in China. In the process of construction and development, we should adhere to technological innovation. In 2000, benchmarking management was introduced as a management tool for technological innovation. 164 production and operation indicators and 45 world advanced iron and steel enterprises were selected. However, benchmarking is not omnipotent. Competitiveness and culture can never be copied. For the rapid development of science and technology, the technical content of products and the complexity of technology used by enterprises are increasing day by day. If only imitation, benchmarking activities are only to catch up with the advanced but the wanted interfaces will flow into the complex cycle of backwardness and branch marking. For example, the interfaces following the cycle as first lag, then catch up, continue to lag behind and catch up again. IBM and General Electric fall into an endless catch-up game and had to withdraw from the copper market. This is not a standard of management. Whether it is a comprehensive benchmarking or a local benchmark, each enterprise has its own characteristics. We cannot mechanically copy to backmatching of enterprises without considering their own characteristics. It's difficult to achieve the desired results or even lose the competitiveness of enterprises. Benchmarking is an ongoing process, not an overnight success. That is all. Thank you.
Okay, thank you, Liu Jiao. Any question from others? You can open your mic. You can ask the question, if any. Any question?
I have the question.
Yes, Chai, please.
Okay. Based on my understanding, benchmarking is like following the other product, their standard and their requirement. Just my question is by us following the benchmarking method only, is it able to surpass the predecessor product and become a better one?
So to
That's
answer
it.
that,
Yeah, Chavizar, can you answer? Anybody from your team can answer?
to answer that question, for me, I don't think that benchmark alone can be used to succeed others products, but we can take others products to learn what they are capable of because they are the competitors, right? So by knowing their capability, so we can either surpass the capability or at the same level of the capability to compete in the market. That's all.
Okay, thank you. Very good explanation. Very excellent question from Chai. Anybody? Any question from others? Okay. I have actually I jot down a few questions here for your team, Shafiza. Okay. My first question, okay, because I found in your slides, okay, you mentioned about the cost factor related, the drawbacks of the benchmarking, right? The first one is cost factor. Number two, I think Liu Jia mentioned just now about the technology, okay, keep changing, okay, every time. But my question back to your presentation, okay, maybe for three of you, I want to ask, okay, normally when we do benchmarking, okay, we always deal with the secrecy. Okay, I mean the secrecy means the secret of the information. Okay, for example, let's say you become a engineer, for example, okay, or you become a manager for your R&D department as well for production department. but and then your colleagues did the benchmarking. Okay, how you deal with the secrecy issue? Okay, for example, okay, I think I do believe some of you have working experience before in factories or in the private sector. Okay, the problem is that when we deal with the benchmarking, okay, the problem is that we cannot control the release of the information to our competitor. Okay, maybe I want to get your opinions. Okay, how maybe based on your experience, or I just want to hear your opinion, how we can deal with this secretly leaked information go out from your department or go out from your company. Okay, Shafizan, your team maybe can answer my question.
I'm not clear with the question. Can you repeat? Because you said that the information go out from the company, meaning that the we ourselves doing the benchmarking, or the
Yeah, okay.
competitors?
Okay, normally when we do the benchmarking, okay, we keep a lot of information, right? So we keep all our competitors, our our own strength, our weakness. But sometimes, you work as a team. Normally in quality management system, you cannot work alone. Okay, but the problem is that you cannot control the information leak from the company. Okay, for example, maybe you have friends working in your competitor's company, and then suddenly you share with them, okay, now we are doing this, and then we want to produce this, and then now we are I mean in progress do the benchmarking for our product. How you deal with this kind of situation, the leaking of information during the benchmarking process?
Normally for me, I don't share my work with others.
Okay. Very good question. The very good question. Okay, that's become your integrity. But I want to hear from Aminu and Liejiao. What is your opinion? Because Shafiza, I think you have experience before working, so you know the situation, right? But how about Liejiao and Aminu? What is your opinion actually?
My opinion is based on reward and incentives
Works and incentive, you mean?
to your
Oh,
customers, to your team workers.
okay. All right. Okay,
If you are
good.
giving them reward and incentives, I don't
Okay.
think they will leak your benchmarking. What do I call it?
Leaking information.
Yes, sir.
Okay, good. Very good. Very interesting answers, actually. Okay, introduce incentive for the staff. Okay, good. How about Liu Jiao? How about your opinion? Do you have any opinion how to deal with this kind of information leaking to your competitors or to your to your, I would say, to market?
Mm, the development of enterprises,
Okay.
continuous learning behaviors, feedback, and improvement.
Okay. Okay, you mean that the behavior of the staff itself.
Mm,
Okay, no problem, Liu Jiao. Maybe later you can answer. Maybe you can wrote the answer in the chat box.
Doctor,
Okay.
can I add more, Doctor?
Yeah, can please.
Normally in working, we have a level of access to the information for every
Okay.
level of staff. So different level will have different kind of information. That's all.
Okay. All right. Okay, you mean that the you know the level of information handling? Do you mean something like that?
Yeah, let's say engineers and managers. A manager will have a lot of information compared to the engineers itself.
Okay,
So,
understand. And okay, good. Very interesting. Okay, but I think based on your presentation, okay, maybe I think Li Jiao touched this one a little bit. Okay, the technology involvement. I mean, the technology become expand and expand and expand. Okay, so the question is it the benchmarking is worth to do? Okay, maybe this one I don't want to take to compare, okay, with this company, okay, but I want to give you example, okay. For example, you're the mobile phone manufacturer. Okay, now in the world we have how to say the I think two or three prominent mobile phone manufacturer. Okay, I think you know the company. Okay, I would say the company A refer to this brand. Okay, company S refer to this brand, and then company H refer to this brand. Okay, we have three brand. Okay, but because I'm a very tech savvy person, so I quite closely follow how they announce the new product. Okay, but as you know, these companies A, S, and H, okay, they did their benchmarking. I mean the benchmarking process. Definitely, they will do. Okay, either they do in the legal way or they did in illegal way. Okay, that's a two different things. Okay, but my question is, when you see the trend, okay, how they announce their new product. Okay, for example, you have the mobile phone company A. Okay, normally announce first. Okay, they are they are produce a more thinner handphone, more high end processor. Okay, more the cameras is improved, and then you can see after 1 or 2 weeks later, their competitors, okay, company S also announce. Okay, they produce the new product. Okay, as you can see, the product, the features of the product is, I would say, very close similar to the company A that just announced the new products release. But for company S, okay, they enhance the properties of their new product launch. Okay, and then come to the company H. Okay, after they've seen the company A and company S announce and release the new mobile phone or new product device. Okay, and then suddenly after 1 month from the company A release the product, they come out with much better features for the phone. Okay, I think you might agree with me with this kind of point. Okay, because if you follow closely, uh, especially the devices, the mobile phones, the computers. Okay, you can see the dominancy of these three prominent manufacturer for electronics products. Okay, company A, company S, and company H, I would say. Okay, but as you can see, how they manipulate the benchmarking. Okay, actually they did the same way. Okay, but inside, before they launch the new product, they did a lot of survey, they did a lot of benchmarking, they did a lot of uh, gathering information. How about their competitors performance, what they want to release. Okay, that's why you can see sometime uh, those company summon each others. Okay, bring this case to the court and claim that their design is their design and this design belong to their design. Okay, it always happens. Okay, that's why I'm trying to relate with the secrecy of the information. Okay, I think Shafiza just mentioned just now, the level of approval of the information is really crucial. I think same goes to Aminu as well. Okay, because Aminu talk about the incentive. Okay, but for incentive, That's why your competitors can offer better position, better salary, and etc. But I think I want to summarize your presentation based on Liu Zhao's statement just now. Okay, Liu Zhao said it's come back to to the person behavior. Okay, person attitudes. Okay, how you hold your integrity, how you hold your responsibilities when you deal this one. Okay, for me the benchmarking is easy part to do, but the hardest part is that how to keep the information. Okay, how to keep the information is, I think, the very hard job lah to do. Okay, that's why some of the companies, okay, you need to sign something like a non-disclosure agreement, NDA form. Okay, you need to sign. Let's say if they found any information leak outside, you might be get penalty by by company, or the company wants bring you to the court, okay, to testimony you. Okay, you are you are, I would say, help the competitors and etc. Okay, that's a very important. That's why I want to bring this issue highlight. Okay, so a very good presentation. Now I want to move to next group. I think,
Thank you, Doctor.
yeah, thank you, Shafizal. Thank you, Aminu, and thank you, Lija, for your presentation. I think it's very good information to share with others as
Thank you,
well.
Prof.
Okay,
Thank you,
so next is the Tan Kai Wen.
Thank you, Prof.
Yep. Kai Wen, you and Tim can share the screen now.
Doctor, can you hear me?
Yeah, can.
Okay.
Okay.
Okay. Good evening, everybody. My name is Tan Kai Wen, and now I'm gonna present the group assignment for the Statistical Process Control (SPC). Our group consists of me, Sarifa Farhana Hamdam, and Wei Yiming. First, I want to talk about how to use the SPC. Before implementing the SPC, a company should determine the main areas of problem in their manufacturing process. It will be effective to apply the SPC to these areas first. During the SPC, not all the dimensions are monitored due to the time and expense limit. So the failure mode and effect analysis can be used to analyze the main problem in the process. The SPC data is collected using the measurements of the product dimensions, for example, the diameter of a pipe. Based on the type of data being collected, the data is then tracked on the various type of control charts. The data can be in the form of continuous variables or attribute data. The data can also be collected and recorded as individuals' values or average values of a group of readings. The most commonly used chart is the average and range chart. The figure below shows an example of the X bar and R chart. For the X bar chart, the subgroup measure is 20 subgroup, and the central line, as you can see, is 45.13, and the upper control limit and the lower control limit is 46.49 and 43.78 respectively. In the chart, all the points are within the control limit, so we can say that the X bar chart is the process is in control. So for the range chart, the central line is 2.345, and the upper control limit and lower control limit is 4.958 and 0. Same as the X bar chart, all the point in the R chart is also within the control limit, so the process is in control. So to calculate the central line for the X bar chart, we take the average value of all the measurement in a subgroup divided by the number of subgroup. For the upper control limit for the X bar chart, we take the central line plus the A2 times R bar. For the lower control limit, we use the X bar minus the A2 R bar. So for the R central line, which is the R bar, we take all the range for all the subgroup and divided by the number of subgroups. The upper control limit is equal to D4 times R bar, while the lower control limit is equal to D3 times R bar. So the A2, D3, and D4 are all constants, and the value can be taken from the table at the right. So the value of A2, D3, and D4 is depend on the subgroup size. For example, if we use the subgroup size of 6, the A2 value will be 0.483, the D3 will be 0, and the D4 will be 2.004. All the data points on the control chart should all fall between the control limits. If there are many points which fall outside the control limit, then the process is deemed out of control. Appropriate action should be taken to investigate the cause of it, and corrective actions should also be taken to return the process to a state of statistical control. By addressing this issue, you can ensure that we are producing parts that meets the customer's requirement. For the interpretation of the chart, we must look at the range chart first. This is because the control limit on the X bar chart are derived from the average range. So if the range chart is out of control, then the control limit on the X bar chart are also meaningless. For the range chart, first we must look out for out of control points. Then we must find out the causes for these out of control points and must eliminate the causes. Also, there should be more than 5 distinct values plotted in the range chart, because if there are values repeated too often, then it means that the resolution of the measurements is inadequate. For the X bar chart, we first interpret the points relative to the control limits, and for out of control points, the special causes for this must be eliminated. After both X bar and R chart values are studied and they are within the control limits, then the process capability studies can be carried out, and the process capability chart, like the chart on the right, will be plotted. So for A, we can see that the graph is very thin and very high. It means that the process is easily meets the specification limits, which is very good. And for B, the chart is more flat and more low in height. So is worse than the A, but still it meets the specification limit. For graph C, we can see the graph touches the lower specification limit and upper specification limit, which means that the process only just meets the specification limits and any shift or spread will result in failure of the product. For graph D, we can see that the graph exceeds the lower specification limit and upper specification limit of the chart, which means that the process is not capable and is a failure. Next, I will pass my presentation to Sarifa.
Hi, my name is Sharifah. Thank you, Tan. I will continue with when to use SPC. We from slide time before can give you an idea on how to use SPC. Now, we need to understand when to use SPC. By first, we need to understand what is SPC. So, SPC is a control chart. This idea and concept that process could be in statistical control.
Sharifa, are you there?
Hello?
Hello? Yeah, I can hear. Sharifa is
Sharifa? We cannot hear you.
yeah, we can hear. Hello, Sharifa? Maybe Tan, can you proceed? Just read the slides so everybody we can proceed because I think Sharifa may have a problem with the mic.
Okay. I think Sharifa is responding in the WhatsApp. I will ask her what happened.
Okay. Oh, Sharifa is out and in back. Tan, Sharifa is okay? I mean the what happened?
I don't know. She says she is trying to change to cable now.
Oh, so she using Wi-Fi.
I think so.
Okay. Okay, maybe the next person can proceed after Sharifa. Who?
Yiming.
Me.
Yiming. You can proceed first, Yiming.
Okay, thank you.
Okay.
Now the final part, I will talk about the industrial related example, the
Okay.
Ford Motor Company. This program is the real SPC manual of Ford Motor Company. The selection program of the control chart described in this manual is shown in the figure. So first of all, determine whether the characteristics of the manual control chart are maintained data. Because the entire flowchart is too large, I divided into two charts for display. So as you can see, this is the half of the whole chart. So and you can see the it methods date. If it is not a quantitative date, the next question is, do you need to consider the rate of non-conforming product? If so, the question is whether the content of the sample is constant. If the content is constant, use the NP or P diagram. And if the content is not constant, use the P diagram. If the rate of non-conforming products is not considered, then the number of non-conforming products should be considered. The question is whether content of sample is constant. Use U or C diagram for constant content. Use U diagram for non-constant content. So please, next slide. Karen? Okay, thank you. Okay, thank you. So if it is a measurement type data, can you sample by subgroup? Examples of samples that cannot be sampled by subgroup include chemical bus, bush pot, etc. If not, then use single value group XMR. If so, then the next question, yes, can the average value of the subgroup be easily calculated? If it's not be easily calculated, then use the median value. If it can be easily calculated, then proceed to the next question. That is the subgroup capacity greater than or equal to 9. If it is not greater than or equal to 9, use the XR diagram. If it is greater than or equal to 9, then go to the next question. Can the S value of each subgroup be easily calculated? If not, use XR diagram. If possible, use XS diagram. Please, next slide. So the symbol used in this handbook, the big C is the number of the non-conformities in the sample. The small c is when sample size is constant and the average number of unqualified samples. MR is mainly used for the range of movement of a series of points in a single value group. MP is the number of non-conforming products in the sample with the capture of N. P is the rate of non-conforming product in the sample. And R is the range of the subgroup. Small s is the sample standard deviation of the subgroup. U is the number of unqualified units per unit in a sample. This sample may contain more than one unit. Big X is a single value, which is the basis of the statistical value of other subgroups. That's all. Thank you.
Sharifah, can you proceed?
Okay, hi. My name is Sharifah Farhana, and sorry for earlier. I will continue with my part on when to use SPC. Mike already give you idea on SPC, the implementation in industry and how to use SPC. So first, in order to use SPC, you need to understand what is SPC. So SPC is a control chart. This concept and idea that process could be in a statistical control. As for company and factory, they tend to focus on something that's hard to difficult to control, like increasing in competition and the cost of raw material. In fact, in SPC, we need to focus more on something that we can control in process to strive for continuous improvement in quality, cost reduction, and efficiency. And in SPC process implementation, offer the company from detection based to prevent based quality control, which means from detection based mean the end product. Before the defect happen, we implement SPC to prevent this base quality control. This real-time process. So SPC is a real-time process. Monitor the performance and help operator to detect any changes or trend in the process before it reach the product and scrap. Okay, next. Okay. Next, to implement the SPC, we need to start by identifying the main areas of waste and inefficiency in company or factory. Example of area of waste like inefficient data collection, inefficient line, over inspection, rework, scrap, incapable machine, and off process, and paper-based quality system. Like Tan said before, not all the mission that need SPC due to the time, expenses, and the production delay. So that's why we need to identify the main area in order to use this kind of control. And below, in the blue word, you can see a few questions that could be asking to quantify the value of SPC solution. These kind of questions you can ask yourself, maybe you as a factory or a company, in order to implement the SPC. For example, the question, can you easily determine the cause of quality issue? Is your data can use the right kind of data be collected? Is it in the right area? And if you maybe already did some kind of data, can your current data be used to improve your process, or is it in the just for the state of data? And the last question you can see, are your quality costs really known? As this quality cost is mentioned by our Dr. Harold mentioned a few times in class about the cost, because we want to implement something right. So cost is something, a major decision for company and factory. Okay, next. Okay, this is my next slide. In the board, you can see with real-time SPC. I can see this like advantages in because you want to implement SPC. So what SPC can do for you? It can help you reduce costs, uncover hidden process functionality, improve productivity, reduce variability, and instantly react to process changes. Why instantly react? Because control chart is a real-time process. So before it become the scrap or end product, it can instantly react to improve, make real-time decision on the shop floor. And next we go to 4 principal objective in applied SPC. This is a 4 objective in SPC. First is process monitoring. So the objective of SPC is to control and monitor and maintain the process stability, which enable improvement in process. Second is planning. Means we use this to maintain schedules that involve a number of applications that derive effective plans and schedule. Third is evaluating customer satisfaction. Of course, when we want to implement something, objective is for our customer satisfaction. So this range of application domain to detect high level of satisfaction and dissatisfaction. And lastly, the 4th objective in applied SPC is forecasting. So forecasting actually is a technique and model that can be considered also as a technical and satisfaction of SPC chart. This type of model and technique can be used to generate and optimize in implementing our SPC. Thank you.
Okay, thank you, Sharifah. Any question from friends?
I have questions on
Sabiza, please.
SPC. I saw the chart show that the upper control limit, lower control limit, but I don't understand how to set that limit.
Okay, your question how to set the limit?
Yeah.
You mean which chart? Hello.
Yes.
You mean which chart?
This step.
This chart.
Okay.
Oh, so here's the formula to calculate it. First, we must find the central line for the chart first. And for X bar chart, it is the sum of all the average value in the subgroup and divided by the number of subgroup. Then we can calculate the upper control limit by using the summation of the X central line plus the A2, which can be found in the table, and times the R bar, which is the range and the average range. And the lower control limit is using minus. So we can find the control limit by using this method.
So let's say when we measure, it's
Yes.
outside the limits. So how we detect that limit is already outside? That measure already outside.
Can you repeat the question? I don't quite understand.
The upper control limit is the
Yes.
what's the hold on. So based on that formula, we can get the
upper control. Yeah. Yes.
Okay. Okay. Thank you.
Oh, thank you.
Okay, good. Any question?
I had a question.
Who?
Chai.
Chai. Okay, Chai, please.
Like, okay, for example, I have a process line. Then, if that process line, their value, their mean, and the range are within our specification, then how we want to monitor or improve the performance of the process line by using SPC?
If all the points are in the control limit, then
Yes.
is deemed as a good process because the point of using this chart is so that we can see how many points are out of the control limit. If too many points are out of it, then it means that the process is not good. But if all the points are inside the control limit, that means that the process is good enough for us.
Okay, so just because this is based on my experience, like normally in the industry, they will deal with quite a lot of chart. Then they have the one of the simple way to monitor the chart performance. Do you know that what is the simple way to monitor the chart performance? Just like without seeing chart.
I don't know.
Okay.
Can you share? Can you share, Chai? Can you share with us?
They are using the method like the CPK performance.
Okay, CPK. Okay. Okay, CPK chart, you mean?
Yes.
Okay. Can you share what is CPK means with them?
Okay. CPK chart is like just the criteria that I mentioned just now. If our data, the mean and the range are within our specification, then this is the next progress that we don't want to see our chart, the trending is consistent or not. So this method is using the CPK method to monitor our trending is okay or not within for example within 1 month, 3 months, 6 months, just within trending. So if the CPK is maintained good, then the engineer no need to concern on their process line. If the CPK is got drift, then they need to take attention to find out the problem.
Okay.
It's-
Okay. Thank you, Chai. I think very good, very interesting. Okay. Okay. I think maybe all of you can find out in in the website what is CPK means. Okay, I do agree. I totally agree with Chai. Okay, because in manufacturing especially, okay, we use a lot the CPK chart. Okay, even we because I want to touch few things here later, but since Chai already raised up the the question, so actually for CPK chart, I think this most I mean the most popular lah chart using in the manufacturing or production line. Okay, not only production line as well, especially for quality assurance or quality department. Okay, they want to they want to evaluate. I think Chai just mentioned just now the sampling, the consistency, related quality. If the CPK chart is under control, so meaning that no quality concern that we should scare with. But if the CPK control chart have a problem, so meaning that they need to retrace back, okay, the processes, the issue where, and then you need to open the you need to open the file to discuss, to retrieve the issue, and there are many factors affected in. Okay, but I think Chai raised a very good question. I think I also not covered that in my lecture, but I think it's good to know that CPK chart. Okay, maybe you can check as well. Anybody want to add before I ask? I have two questions for your team, Tan. Any question more from others?
I want to add a bit.
Who? Sharifah?
Yes.
Okay, please.
For SPC, the data can be collected and recorded as individual value or an average of group. So what Chai see in time presentation is in the range. But if you think that's complicated, SPC also actually can be used in individual value. And Tan also mentioned that a few them we do not measure all dimension. We due to the time, expenses, and also can cause product delay. So you put that dimension that relate to your process. And SPC, because like Dr. mentioned just now, CPK can measure and involve many factors, while in SPC is focused on the process. Benchmarking is the product, measure the product, services, process, while SPC measure the process only. So if you think from this figure, very hard to understand, actually you can use as individual value or average of group. Thank you.
Okay, good. Anybody want to add more or question from others? Okay. Anybody? Because I saw Yiming switch on the mic. If you want to ask anything, Yiming.
No.
Okay. All right. I have two questions for Tan and the team. Okay. Can you open the dumbbell shape graph picture diagram, Tan? Okay. All right. This one I want to take your attention here. Okay. Again, as I mentioned in my class, okay, I always repeat that for SPC especially, okay, they have I would say the ideal shape of the graph. Okay, I think Tan and the team has I think give a very good example. Okay, actually he in this diagram, okay, already explained. Okay, what happened if the peak is become narrow? Okay, you need sorry, you need to understand, okay, what is the LSL or what the USL means. Okay, for LSL normally lower spec limit, USL is upper spec limit. Okay, but in SPC chart, okay, in SPC process, okay, this kind of chart is really important. Okay, but maybe siapa-siapa later on who let's say you deal with the quality control issue, or you working in quality department, okay, you might see this kind of graph. But I want to take your attention, okay. For me, you need to understand how to elaborate, okay, this kind of dumbbell shape graph. Okay, what happen if if they become narrow? What happen? What is the ideal ideal shape? And then what let's say if the distribution of the point is exceed the USL or lower than LSL, what happened to the process? Okay, is it fail, something like that? But I think Tan mentioned Tan mentioned some in his presentation just now. Okay, he will say, let's say it become narrow meaning what? Okay, it become broader meaning what? Okay, but I want to remind you, okay, maybe I want to advise you, okay, for me, not remember this graph, but you need to understand how to explain. Okay, because SPC is really really important and very famous question uh, in final exam. Okay, because I cover this class almost 3 years already, so I always ask about this. Okay, but of course the question might be complex, but my concern is that you must understand how to elaborate. Okay, maybe later I will share this slide with you all in the in the e-learning portal. Okay, if I forget, please remind me. Okay, or you can share with others as well, but this kind of record session I will share later with you. But again, based on this, okay, can you because I think Yiming, can you go to the flow chart? I think the last two slide. Tan, can you show to me? Yeah, this slide. Okay, this slide. Okay. Uh, in this slide, I think I jot down some of the information. Okay. Yiming said about the non-conforming product and conforming product. Anybody can explain to me what is the non-conforming product means? What is the conforming product means? This is really important. You must understand this. NCP and CP. Okay, what is the NCP means? What the CP means? Okay, anybody from your team or other friend as well can explain to us what is the non-conforming product means? What is the conforming product means? Anybody? Especially from Tan and team.
Hi.
Sorry.
So,
Who? Yiming?
uh,
Sharifah?
from my understanding,
Okay, Sharifah, okay.
non-conforming product is a product that do not meet specification and requirements. That's why I put also in my slide non-conforming and scrap. We do not want that.
Okay, all right. Okay, that's a okay. But I mean, good explanation. Others, other understanding. I want to hear from you. What is your understanding about non-conforming? This is really important. You must understand in quality control. Okay, you must understand normally when you go to company or factories, plants or a production line, they always talk about this non-conforming NCP, NCP. Okay, they will say, okay, how about your NCP? Do you have any NCP issue? You have CP issue? Something like that. May I know other opinion about how about your understanding about NCP or CP? Conforming product and non-conforming.
For conforming product, maybe they will add some subgroup in the process.
Okay.
So the non-conforming product will not. That's what I think.
Okay. All right. Maybe if you have paper or notes on your table, okay, I would prefer if you can find out what is the non-conforming and conforming product means. Okay, it's really crucial. Okay, for not SPC. Of course, NCP and CP is a part of the SPC, but I mean the definition. Okay, how people use the NCP, when people use NCP, how you describe the NCP. That's really important. Okay, when you want to use CP, okay, what CP means in quality control. That's really important. Okay, so I think you should jot down some. Okay, you need to find out this information. Okay, and add in later. Okay, I think the second group did a very good presentation regarding the SPC. Okay, so the last group, Chai, for FMEA.
Hello, Professor.
Yeah.
I share the slide.
Okay, please. Ting, eh?
Yeah.
Okay, please share with me.
Can you see the slide?
Yeah, I can see. I can see the slide.
Okay, I begin my group. Our group include the Thai, Susan and me.
Okay.
Our chapter is about the FMEA, so I to introduce the FMEA. The FMEA actually it is a true and a method. Yeah, sorry. A method to a method to provide the new process or the new products, the filer before the process or the product produced. So and it to evaluate the new process and will to occur the failures, include the steps in the process under the final model. That means what would go wrong and the final causes. That means why would the failure happen, and the final effects. Then what would be the consequences of the failures, and it should to give some actions recommended to improve the process, and to and finally we will obtain the result. Some recommended the result. I like to talk about the purpose of the FMEA. That is to find the potential failures in the field process or products, and to eliminate the potential values, and to improve the process and the protects. And we elect a process to focus to explain the FMEA process, and because the China have experience in the manufacture the chip, so we select one of the process. We select this is the total chip, the process, and we select this the implantation, the IO implantation process for applying this process. So this is the IO implantation process. The follow. This include this conducted before I mentioned the step of the process. So the process includes the emulsion design and making fine masking file formation. Sorry, and ion implantation, the cleaning and the test, and so we to analysis this process is a high rise. And the FMEA actually he implement before the process or in the design step. So I introduce this about the implantation the process. This include this is actually it is the high requirement for the equipment, and so this is the structure, the requirement structure, and and to further operation is the low requirement, and for the high requirement for the high requirement for the equipment. So we should cite some payments. This part the payments we should cite, and no other operating, and it's a high requirement for the equipment. For this process, have some in the quality tester or the quality control. Mainly include this for the number of the particle and yeah. I'm sorry, I forgot to introduce the wafer. And the first is the number of particles on the wafer surface. The two is the payment dose. Where these elements to control or to test, and the price of the scrap on wafer surface and presence of other elements on this actually the conclusion. This actually the conclusion the other elements. Then sorry, the next part is for the hello.
Hello. Yeah. I can hear you.
Okay. Let me show my screen.
Okay.
Okay. Okay, do I show my screen?
Yeah.
Oh, okay, Professor. Let me begin. This is another part of the FMEA. We focus on the implementation process.
Zufing, I cannot see your slides.
Oh, cannot see, huh? Oh,
I can see the slide.
Oh, really?
Roger, is that okay now?
Can you go next? Next?
Next. Oh, okay.
Yeah,
This
okay now. Okay now.
Through our analyzation, we think the potential future failure mode is that situation. One is wafer charging. The two is particle contamination. Third is channeling effect and elemental contamination and implant damage and wafer scratch and wafer breakage. This is all can let the product failure. So we next analyze the potential causes. They are one by one. To the wafer charging, the potential causes may be the beam certain or the rotation speed. That means, for example, the rotation speed is not too high or too low. It should be at a speed range, so the process can be done successful. Another and third and next failure mode particle contamination. The potential causes may be large particle contamination on wafer surface. The channeling effect is related to the ion in this distance is constant with the internal non-lattice channel. And other three causes related to their potential cause. And the next is we analyze actions requirement is on the right. Okay, the next part our team let the Chan to introduce. Thank you.
Okay. So you are the last one, right? Present.
Yes. Okay.
Okay. I open any question from friends.
Oh, I still not yet.
Oh yeah. Okay. Okay, Chan, I forget. Okay, please.
Okay.
I thought you already present.
Let me see. Okay, can anyone see my slide?
Yeah, can.
Okay, for my part, I will explain the next process for the FMEA to set up. Just now my teammate Zhufei had explained the step by step for the FMEA to set up, right? From the failure mode, causes, and to the action recommended. Now, continue for my part is based on these three factors. We want to put on the ranking. It's like put on the numbering system on this factor. Right? For these are the three major part that we want to do the ranking, which is for the severity, probability, and detectability. As the higher the number, there is like the person in charge need to pay more attention to look after the problem. Like for example, the severity as the higher the number means that the risk is much higher. Then that probably will cause some very disastrous problem and may cause the huge amount of the cost to be lost. For the probability means that the chance of happening is high or low. And the last one is the detection. As the number of the detection level is higher, means that maybe the failure is very hard to be detected. So and causing the failure is continue to happen, and someone may like overload. So based on this FMEA, we can conclude that through the ranking system, if the numbering level is, we should like make it as low as possible. And next, this is the considered as the final product of the FMEA. Finally, we have the item function.
Okay.
Remote effect. This is a severity, failure cause, occurrence, recurrent control, and repetition. These are the table of the FMEA that are compiled into the table list. And this RPN is like the it's like the summary of this three number. So means that they are calculated by the total multiplication of these three number. So as these number are higher, as the higher means that we need to pay more attention and be very serious to this kind of the problem. So basically these are the FMEA example for this implementation process. Okay, that's all for the presentation.
Okay. Thank you very much, Chai. Any question from floor? Okay, I think for you it's quite complicated, right, to understand the FMEA. Okay, I think Chai and the team, okay, give a very good example, okay, how they did the FMEA analysis by using the wafer, silicon wafer, right? I think, Chai?
Yes, silicon wafer.
Silicon wafer ion implantation. I mean, you dedicatedly identify the function of the wafer, right? The process involved in. Okay, I think Chai and group shows a very good example. Can you go back, Chai? For your last two slide.
Okay.
Okay. Before that, can you go back? Okay. And another one. Okay. So, actually, when we talk about the FMEA, okay, this kind of the brainstorming is really important. Okay, to identify the potential failure mode. I think I already mentioned to you in the class. Okay, in order to rectify the causes that might affect to the process, okay, you might use as well other QC tools. For example, fish diagram, survey, histogram, whatever a QC tool that you have. Okay, and then later on you need to tabulate it, and then you need to identify, okay, the potential as you recommend just now, okay, wafer charging, particle contamination, channeling issues, the elemental, and then etc. Can you go back next, Chai, the slides? Okay, and then based on this issue, okay, there are more detail, okay, identify the cause, okay, because based on the potential failure, okay, and then they will identify again what is the potential causes to that failure. Okay, for Wi-Fi charging, and then for Wi-Fi charging, beam current, rotation speed, but all these causes and all these failure mode, okay, you need to do as a team. Okay, you need to get a survey, get the data, statistical analysis to see the potential causes that affect this kind of failure mode. Can you go next slide, Chai? Okay, this one become the recommendation. Okay, when you identify the failure mode, the potential causes to the failure mode, and then you need to tabulate what is the action that we should take, okay, in order to improve the ion implantation process. Can you go next slide, Chai? Okay, and then correct me if I'm wrong, Chai. Based on, can you go back to the previous slide? Okay, based on this action recommendation, and then you need to tabulate the data. Can you go next slide? Okay, and then from this, you need to, I think Chai just mentioned just now, okay, you need to categorize, okay, all these parameters into the ranking. Am I correct, Chai?
Hello, hello.
Hello, yeah.
Okay, yeah, it's correct.
Okay, and then from the ranking, you need to prepare this table. Can you go back, go forward, Chai?
Okay, this one.
Okay, yeah, this one we call the FMEA, because I think the FMEA table, I think is quite standard. Okay, for every processor, because for FMEA normally, if we deal the FMEA, we have the standard table like this. Okay, what is SEV? I think Chai already mentioned the severity, right, Chai? SEV.
Yes.
Okay, and then the OCC, the occurrence, how many times this issue happened. Am I correct?
Yes.
Okay, and then RET, I forget the RET.
It's actually typo is DT, detection.
Okay, okay. Normally TD, right? The DT, right? Normally.
Yeah, DT.
Okay, all right. And then the RPS, I mean the cycles of the
RPN is like the total summary value of these three factor.
Total summary value.
Yeah.
Okay, all right, I understand. Okay, and then the action recommended, right?
Yes.
Okay, and then the empty space, normally you need to fill in once you take all this action. Am I correct?
Yes. Normally, if the problem happen, the person in charge may do some action checking. Then they may fill in the action taken. Like who is the person in charge? What are the action taken, etc.
Yeah. Yes. Understand. Okay. So okay. So it means that, okay, I think Chai and team for me shows a very good examples for FME. I would say, can you go back, Chai? Previous, I think 4 to 5 slides. Can you go back more? Okay, go forward. This one not so important. Go back. Okay. I want to say from this slide until the end of the slide, okay, it's really important actually. Okay, how we deliver the FMEA analysis. Okay, number one is that I think for failure, FMEA means a failure mode effective analysis. Okay, normally we want to predict the future. Okay, we want to predict what happened, causes to the failure mode, and then affect or not the process or the product quality. Okay, so therefore, in order to understand the FMEA flow, okay, I think you should listen back this recorded session. I do understand you quite little bit confused about the FMEA because the FMEA is I would say is quite complicated. Okay, failure mode, but this normally exercise in industries. Okay, but I think when you work in especially semiconductor. Okay, there is a lot of this FMEA. Okay, because maybe do you have experience hear the words back end technology and front end technology? You have any experience? I think, or this one your first time you hear?
Yes.
Okay, Cha, you have experience before, right?
Yeah. Hear it before.
Okay, back end technology and front end technology, correct?
Yes.
Okay, normally this kind of back end and front end they use a lot of this FMEA. Okay, because in semicon, okay, the technology is evolved very quickly. Okay, for example, I give you one example, Intel processor, right? Intel processor. Okay, before this, the Intel evolving technology is very fast. Okay, this month you launch new product, another 2 months they come out with the new ideas or new things. So therefore, this kind of FMEA keep changing, keep cycling, and keep moving. Okay, because based on the action, based on their, study. Okay, they will say, okay, let's say they want to change from i7 to i10 core. Okay, what happened if we change to i7 to i10? They're forcing the problem because in semiconductor, I would say we need to minimize the failure. Okay, if we cannot do that, I think it's loss lah for the company. Okay, because for semiconductor, I would say now they almost go to autonomous or robotic production. That's why they can minimize the failure. But in order to do that, okay, they need to analyze. Okay, that's why the prediction analysis is very important. I love to say, normally FMEA we can call as a prediction analysis. Okay, based on the process, current process, what you see from the potential failure, and then from the potential failure, what is the causes related to the potential failure, and then what the action recommendation to improve this kind of causes and failures. But from this action recommendation, actually you can predict, or you can see whether, okay, this process can be enhanced, can be expand. Let's say either certain volumes, or maybe, okay, let's say, okay, actually we can install another kind of separate process in order to complement the complete cycle of the production process. Okay, I think that's all from my side. Okay, I think this almost 2 hour session is quite. I think I'm very happy to see the presentation. Okay, actually I'm very happy to see you doing this because I want to check whether you understand or not. The fundamental. Okay, to say I'm expert, I'm not expert at all regarding the quality management. Okay, I'm not a quality management practitioner, but I teach you based on my experience, and then I teach you based of my observation, based on my case study. Okay, so I hope this 2 hour session give you benefit and you gain some information. But I do again, I jot down some here. Okay, for benchmarking, you need to understand the advantages and the drawbacks. That's the number one. Number two is that for SPC, I think you don't need to I think you don't need to remember how to calculate and make the graph. Okay, the important is that you need to understand how to elaborate the graph. Okay, what the parameter must be contained in the graph, the UL and the UL and LL. Normally I always says upper limit and lower limit at L. Okay, but sometimes people change to LSL and USL. Okay, so you must understand this, and then you must understand as well the double shape pattern or the double shape distribution. Okay, what happened if we can say, okay, our process control is, I would say, in good condition. Okay, when we can say our control quality, I mean our quality control is failed. Okay, and then when we can say our quality control need to be improved. That's really important for SPC. And then again for SPC, I think Chai mentioned just now in previous presentation, the CPK and the CPK chart. Okay, you need to find out what is the CPK chart means. Okay, that's number two. The number three is that sorry, for SPC as well, you need to understand what the CP and NCP. Please find the information for NCP and CP. That's really important for you to understand. Okay, the last part for FMEA, I think you can use Chai and the team example, especially for wafer, for ion implantation, how they did the FMEA. Okay, of course you cannot remember how the tables look like. Okay, at least you understand how the FMEA works. Okay, start from the analyze the potential failure and then the potential cause, and then from the potential cause they come out with the actions, and then the action must be delivered based on the FMEA analysis that they made. Okay, you need to calculate how you get the severity, occurrence, the volume, and then as well the action taken from the table. Okay, I do understand the FMEA is quite complicated, but I think it's worth to understand, because the FMEA, especially when involved in high tech business, okay, for example, the mobile device, computer, processor, chips, and etc. I think they use a lot of FMEA. Okay, so I think that's all from my side. Any question from your side? Okay, for tomorrow, maybe our class roughly around. Okay, our class is normal as usual. Tomorrow 4 to 5, but maybe I just take 30 minutes or maximum 45 minutes for the class. I just want to wrap up my topics for the past 6 weeks. Okay, what you should understand, or what you should taken the point, and then what you should understand regarding the content of the topic. Okay, and then after Christmas. Okay, after Christmas, Prof. Zanovia will in charge the class, and then she will cover the management, leadership, and teamwork, I think. Okay, so I think that's all from my side. Any question from your side? Okay, this session I will share later once available in e-learning portal. Okay, you can refer back this recorded session. Okay, can you write in the chat box if you don't have any question, so I can close our session for today. Thank you very much for your cooperation. I read already your report, and then I'm very happy to see your presentation today. And yeah, inshallah I will see you tomorrow around 4 to 5. Okay, so Walaikum salam. And then later I will share with you the meeting link. The meeting link maybe, I mean, if not tonight, tomorrow morning. Okay. Yeah.
What I'm saying is, let the group share the content so that we will have what they present in the WhatsApp group, each group.
You mean the slides?
Yes.
Yeah. Okay. Maybe no problem. Maybe you can share your slide as well in the groups, so people can download easily inside phone. Maybe later you can do it. Okay, but the record session, if you want me to put in the WhatsApp group also, no problem. I upload in my YouTube, and then I share with you in the group. No problem.
Okay, Prof. Thank you.
Okay, but the slide you can share in the group, no problem. Okay, please upload the slides. Okay, any question more from your side? Okay, if not, thank you very much again for your time and see you tomorrow. Okay, bye-bye. Assalamualaikum and see you tomorrow.